So carrying on with our Hope Centennial high traffic classroom work example, we're looking at a specific client and we see that there was this huge amount of bandwidth. We can't actually see right now whether that was transmit or receive, but I'm going to guess it was receive. Now, what we now want to look at is what speeds were achieved. So remember that when a client accesses the radio channel, it has a certain amount of data to transmit, and the speed at which the data will be transmitted depends on conditions in the channel. If conditions aren't good, then the speed will be slower, and therefore the client or the access point will occupy the channel for longer. So high speed is always a good thing. So we see that from 850 through to probably 924, we have this histogram, and we see that most of the data was transmitted at the top speed, which is 144 megabits per second. We will see that there was a little bit of 54, some 130, some 117. So most of the data transmitted at high speed. We also see that there is some low speed. Now, this low speed tends to occur when the channel is not busy and when there's a requirement to save transmit power, because you can transmit with lower power at a lower speed. Now, I was thinking about this and why would an access point want to transmit at a lower speed and lower power? Well, I mean, the reason might be that if there's a risk of two access points interfering with each other, it is beneficial for the access points to decide that they will drop down their transmit power, which is literally how loud they're speaking or shouting, in order to minimize the chance of interference. So that would be a reason why you would sometimes see this. But the important thing is that in general, the channel is good enough for the access point to be able to transmit towards the client at the highest speed. And that's healthy. So let's look at going the other way, which is the received bit rate distribution. And remember that there was very little traffic going that way. Most of it is simply acknowledgements. And you can see that while the client was certainly able to transmit at the higher speed, quite often it was transmitting at only 6 megabits per second. And typically what you'll see is the laptops will transmit back towards the access point at 6. The access point's slowest speed will generally be 18, but this is still okay. Again, I see this as indicating that the laptop is running on battery and wants to save power by transmitting at a lower level and slower speed. But the fact that we could see that it's consistently been able to achieve high speeds over time tends to suggest that things are quite healthy. So what we can do is we can close this particular client down, and we'll just look at one more before we close the video. And we'll look at one that's transmitted a lot of data. So we've got some 0.5 gigs, and that seems to be the most. So here we got a 0.59 gig with a very high 49 dB signal to noise ratio. The interesting thing about this one is it's actually on the 2.4 gigahertz band. So that would be a good reason to look at this one rather than the previous one, which is on the 5 gigahertz band. So again, we right click and open this one. And looking at this one, this traffic pattern is indicative of a device on which there's been probably no interactive activity, and that what we're seeing is probably some updates. This is a Windows 7 Vista system. So what it's also showing is that there's a very similar number of transmitted and received frames, and that suggests there's more or less a one-to-one ratio between every received frame and an acknowledgement of that frame. We look at bandwidth. So we peaked around 5 megabits per second. And we obviously dropped off, and here we see a little bit of interactive over here, but it's still very low. That's 810 kilobits per second. It's less than a megabit per second. It's pretty slow. So if we look at our distributions, lots of green and blue. We know this is healthy. We can see that this was up at 144.4. So the interesting thing is that although this client is connected on the 2.4 gigahertz band, I would be pretty certain that it is 5 gigahertz capable. Because when a device can go above 65 or 72, that means it's got a 2x2 MIMO wireless adapter, and those are normally always dual band. Okay, let's look at our receive bitrate distribution. And again, we see the typical occurrence of 6, but the fact that we see 144 and 130 and 117 suggests that we've got a healthy client. Okay, so that concludes this video. I just wanted to give you an idea of how you would potentially, perhaps come in one morning, take a look at your own school site, focus in on what looks to be your hotspot for this day, and check it and make sure that everything looks healthy. And what you might want to do is, having seen that things look healthy, go and talk to the teacher in that classroom to ask them about their experience. And especially, I would guess, when you see things that don't look so healthy, talk to them more pointedly, because you would be looking for, correlation between what seem to be issues and the user experience. I'm actually going to try and put together a video for a site where there is an issue, but of course, our wireless is so good that there aren't many wireless issues. I mean, I know that sounds like a joke, but it's actually true. Most of the issues that you will be finding are not to do with your wireless networking. They seem to be generally to do with issues on the Windows clients that tend to get blamed on the wireless networking.